Hello, I am Abhishek. I heartily welcome you to the tutorials on XFLR5 software. What is it all about? What are the outputs? What do we learn from here? And all we will be discussing in this series. So let's get started. So what is actually XFLR software is about? It is analysis software. You can analyze aerofoils, wings, airplane body, empennage, and wings will be compulsory out there. And moreover, you can also do stability analysis on aircraft or wing or the structures what you reproduce out there. So let's get started. What is XFLR? Let's take it to a what is XFLR all about. So basically when you open, let's get started. This is XFLR tutorial part 1. So let's get started. This is XFLR 5 version 6.47. This is how it looks. So you can switch from design to analysis, from wing analysis, Xfoil analysis. You can switch out here, or you can press Ctrl this one. You can save new project and all. So let's get started with the new project. Let's first the very first step is to design an airfoil. So yeah, let's get started with designing an airfoil. So go clicking on foil menu, find NACA airfoils out here. So you can give NACA numbers out here, like NACA digits, 4 digits. You can go with 5 digits also. So let's get started with NACA 2412 with number of panels. Yeah, the panels are these things like between two nodes is what one panel is. Like out 100, let me give 200 for better study purposes. Yes, yeah, you can rename this NACA 2412. Let me retain it, which is by clicking overwrite. Now you can make it disappear by clicking on this show out here. This is what everything about airfoil is, like what the thickness percentage. This percentage is about it with respect to chord length. At what distance is the thickness this much? Is this distance? The gimbal at what percentage? At this. And yeah, the number of points, tailing edge flap, if there is flap out there, trailing edge. Okay, yeah, everything is, this is just a simple airfoil. So yeah, this is 0. There isn't any flap, hinge or anything out here. So yeah, this center line, by clicking center line, you can see the chord out here. The chord is the line joining leading edge and the trailing edge. This is chord. You can say chord is the center points, like connecting the center points of leading edge and trailing edge. It is a locus of the center points. Yeah. So you can change the color of the airfoil because the background is a bit dark. You can opt for light colors. Light colors, yeah. You can change the width also. You can add a style, let it be simple one. You can also add points out here. So yeah, okay. Let this be a simple NACA 2412 airfoil. Yes. So let's get started. This is first tutorial on XFLR5. So let's get started with a simple analysis, like the very first step is to define airfoil, which is done already. Now we have to analyze. There are basically two types for a airfoil analysis. You can either go with inverse design, which actually is a designing an airfoil for a given CL. If you have already a CL values and some other inputs, then you can go and design an airfoil out there. Now let's start it. Now let's start with analysis. Let's get started. So by clicking on it, this screen appears. I will put the videos on CL versus CD, like what do we get from here, CL versus alpha, CM versus alpha in my next tutorials, like what are we expecting out here, and yes, everything about it. So if you were to have two or more airfoils, you can change here. Let me give one more airfoil so you can understand better. So direct foil analysis, see, you can, whenever you require, you can switch out here. Okay now, so let me define one more airfoil. Naka, let this be 012 symmetric. Okay, okay. Naka, let me overwrite it. Let the name be the same. Let me put the color yellow. Give me giving it the width. Yes, now defined it. So let's get started. Foil. Okay, yeah, Xfoil direct analysis. Yes, now you have option to choose between airfoils, right? Yeah, so let's start with Naka 2412. So yeah, you cannot really change out here anything until you define analysis. Yeah, the analysis you can define for a particular Reynolds number, then opt for define an analysis. If you were to do for group of Reynolds number, like you have a list altogether, then opt for batch analysis. So let's go with define analysis. So yeah, uh, this is by default the name for analysis. T1 indicates something, but yeah, Reynolds number is zero point 0.1, which is 1.1 lakh, 0.1 million. Sorry, this is 0.1 million. Mark number is 0 out here. So yeah, it's 0 and n critical is 9%. So this is type 1 analysis. Why it is always about Reynolds number and Mach number, in the next video I will briefly discuss about it. So let the Reynolds number be 1 lakh, Mach number be 0, then yes. Now you can, yeah, now you can start your analysis settings. In analysis settings, you can start with -5 degrees. If you were to do for differentials, then give with start, end, and the increment. So let us go with alpha only. Start with -5 degrees, end at 20 degrees with an increment of 0.1 degree. So tick viscous initial boundary conditions. Yes, yeah. You can also change the color of the graph, like plot. You can change the thickness. You can opt for different colors. Let the blue for Naka 2412. Now, yeah, after doing all this, if you were to change the colors, like when I choose this, right? Like when I put the tick on this, when I select, when I check this box out here, I get same curve, same colored curves, like see out here. Analyze. This is drag polar. This is CL versus alpha. Stalling point we get from here. This is CM versus alpha. We get, what do we get from here? CM versus alpha. We get static stability point and ring point. CL versus X. I don't really know what is this about. We'll talk about this in next tutorial. CL by CD. This always reach some maximum value. Okay, so it says some of the points are not converged, but it's okay. So these are CL versus CD, and yeah, we will discuss more about this in next tutorial. Okay, now so now you can also go define wing and plane design. Yeah, so very first we have to define an airplane, actually a complete airplane. So define a new plane out here. You can name the airplane some by random, let it be plane name itself. You can give the body, you can define body, you can you have to define main wing. This is by default checked. You can either have biplane or not. If you have, you check this box out. You can have elevator, you can have fin. If you don't want, just simply uncheck this. Yeah, so let's define wing. So by clicking on this, we get to this screen. I would say you better change or don't change wing name. Let me put as flying wing. Fly wing. Okay. Here you can change, like you can give the code, like the red color appears out here. See, when you switch out here, the red color comes out here. Yeah. You can offset it actually. Let's give chord to be 3.3 meter. The chord becomes 0.3 meter. If you need offset from this origin to somewhere, you can give the distance, like I want 0.3 distance away from this origin. Okay, now if you were to give dihedral also, there is an issue. You can give dihedral of 5 degrees, maybe something. Yes. Yeah. You can actually give the twist also. Okay. So maybe then defining this, let the distance be 1 meter from the origin to the tip of the wing. This tells, okay, let me give 5.5 meter, which overall becomes 1 meter. You can see here the span. This is actually for half of it because we have chosen symmetric here. Okay, so chord be 100, maybe like 0.1 meter. Offset, let us, yeah, this is always true that in the isometric view, the plane supposed to be facing towards you, right? This supposed to be this side. Like you, let it be 8 maybe. Yeah, so let me remove this, keep it as 0 only, offset. Yeah, then define this would be small number won't be a problem. So yes, having done this, yeah, then most importantly you have to select the airfoil. Yes, the airfoil out here. be NACA 00, NACA 2412 and NACA 0012 out here. And when we choose panel, let me change the color to black for better appearance. You can see the panels out here, like small panels out here. If you want to increase the number of panels for better accuracy, you can do it. I would recommend to go up to 20, which is quite good for analyzing. So 20. Okay, so this is fine enough. You can let this be a default one. So you can add sections out here. Okay, I need a section right after this point. Okay, not this point. So I have to choose smartly, right? First be here, then insert after section 2. Yeah, you can see here. And this distance you can change, like this is now 0.050. It is, you can change it to 50. Okay, 0.5, let it be 6, so it will be 0.1 meter. Okay, 0.1 meter. For better, but like if you need a winglets out here, let this be 0.5 itself. First we will deflect this airfoil to 90 degrees for better. So yeah, there is an extension, but it is hidden because it says the it retains there only. Chord is a bit less, so let it be same chord. 100 itself, 0.1 meter. Offset is also same. Diagonal, now I will give 90 degrees, which would be like giving a winglets out there. Okay, there isn't twist. Yeah, same thing. Now it is very important to see, like I've given 90 degrees here, right? So insert a section after 3. Now you see, yeah, this will be like a section. Every time you press this section, there will be an extension, right? Yeah, so let me delete this. Okay, let me give length. This be 500 only. As I said, it should be joined. Okay, now let it be 0.2. Oh my bad. It tells the length. Okay, let it be 1 meter, 0.1 meter. Yes, okay, of bit less chord, maybe 0.01 maybe here. So yes, let me give a bit blunt, maybe going with 3 maybe better. Yeah, then this isn't making more sense. Going with 7 maybe better. Yeah, now important thing, giving an offset. We don't need the winglets like this, but rather the winglets itself to be offset or something. Let be 7 maybe. Let's get 5. Yes, this looks good. Depends upon your requirement. Or you can change the airfoil for this also as well. That isn't an issue. Okay, here are the values like what is the wingspan, area of the wing, the projected span, everything is out here. Okay, you can actually add masses also here. Let me show you how. By clicking foil names, you can actually get the foil names also. Okay, I have to take this right here. So this is Naka 212, like Naka 0012, Naka 0012, 1212, and this middle one is Naka 2412. Okay, so let me show you how to put the mass. Save this. Now, plane inertia, you can give the mass of the wing. Let me give it as 0.8 kgs for the wing. If you have any point loads, definitely there would be a payload, propeller, and you can give that like where it is located using coordinates and the mass of it. Yes, let this be a simple flying wing. Flying wing. Okay, yeah, wing mass is 0.8 kgs. Let me save this. Yeah, save. Now when I put tick on this, yeah, you can see the concentrated COG, center of gravity, which is mass, like center of mass for the wing is 0.8 kgs out here. We have to also look that CG should be forward of CP, like aerodynamic center for the airfoil, like for the wing should be behind of COG. We have to look for that. Then we have to properly design, like giving the mass here or here. We have to choose properly. Okay, so yeah, that's all. In the next videos, more about this. You can here you can give the analysis, define analysis. Yeah, important thing. You can opt for lifting line theory, horseshoe vortex method, ring vortex method, and 3D panels as well. Okay, so let's do it. Define analysis, analysis type. Also, let it be non-viscous. Save sequence from -5 to 10. Let's say analyze. Yeah, so this is what analysis is on a flying wing. So let's get it animated. You can see the animation right here. Let me increase the speed. Yes. Okay, let me uncheck this. You can see the CP out here, like how is velocity changing, like center of pressure changing with changing angle of attack. Or you can stop animating. You can select appropriate angle of attack, then you can check like what is the CP out there. Yes. Now what's the lift here? Let me check with the front, like top view. This is back view, side view, top view, plan view. This is better, I guess, for isometric view. And this is the induced drag. The orange color one, the green color one is for the lift. And let's animate. Yes. like how it is changing. Induced drag is increasing with the angle. Like I have give 10 degrees, it will go up to 10 degrees only. How is lift changing? Lift, yeah, from 0 to 10 degrees it would be upward, from 0 to -5 it would be downward. So like yeah, it's switching. The lift is coming out of the screen, yeah, and going down. Yes, that's true. So this is all about XFLR. This is part 1 of this series. In the next video, you will get to know like why Reynolds number and Mach number were changed, everything about this, why using LLT theory, lifting line theory for analysis, everything about it in the next tutorial. Thank you.
Tell me pretty lies, look me in the face. Tell me that you love me.